Thermoregulation. Thermoregulation is where we maintain a balanced internal temperature close to 37 degrees Celsius to prevent damage to important organs and prevent damage to important molecules. Key organs that we need to protect are our brain, as well as our heart, lungs, and the internal organs that digest food, and important molecules, particularly enzymes, which can be damaged when our temperature rises much above 40 degrees centigrade. So we need to maintain our internal body temperature very close to 37 degrees centigrade. And we do that in a number of ways. First of all, we need to find out what temperature our body is detecting. So we have sensors in our skin. So we have heat receptors and we have cold receptors that are in our skin, and they send nerve messages to a particular area of the brain called the hypothalamus. And the hypothalamus can detect variation outside of 37 degrees centigrade. It then communicates back to various areas of our body. For example, it can talk back via the nerves to sweat glands. Sweat glands will start to release sweat if we are too hot. It can talk to the muscles that control whether our hairs are standing up or lying down, and that will change depending on whether you're too hot or too cold. It'll also talk via nerves to muscles in our arms and legs, which can make us shiver if we are really cold. And via hormones, it can talk to our liver to change our metabolism. And in the winter, our liver will be more metabolically active to release more heat to keep us warmer when it's generally colder. So if we're too hot, let's have a look at what might happen. You can see a picture of this lady here. She's too hot and she is experiencing several body changes that will help to bring that temperature down, preventing damage, particularly to her brain and to her enzymes. And these changes include hair muscles relaxing so they lie flat so heat can escape, sweat being secreted from the sweat glands, and this will cool the skin by evaporation. Blood flow into capillaries that are close to the surface of the skin, and you can see this in this diagram. You can see blood flowing into capillaries that are close to the surface of the skin. This makes us look red, but it allows heat loss out through the skin into the environment. And so what's happening is all of the vessels are becoming widened, vasodilation. We can also do things that are called cooling behaviors, and these might include fanning yourself, drinking more water so that you can sweat more easily, wearing a hat, and seeking shade. Now, if we're too cold, we can kind of do the opposite. So let's have a look at the sorts of activities we can do when we are too cold. We can make our hair stand on end. That will allow us to trap hair close to our body, and that will trap hot air. Trap hot air close to our body. We will make sure that blood does not flow in those capillaries close to the skin. So do you see how the capillaries are still there, but they are not full of blood because the vessels have constricted and got thinner just at this point here, meaning that the blood is going to flow away from the top of our skin. So this means we're going to look paler when we're cold. We can also do lots of warming behaviors, and these might include increasing our metabolic rate. So I spoke about the liver earlier doing more work so that our blood gets warmed by it. We could shiver in our muscles in our arms and our legs, or we could simply add another layer of clothing to keep warmer.